Imagine this. You're sitting in your room, maybe scrolling through your phone or playing a video game, when suddenly, a glowing apple falls right on your head. You'd be pretty surprised, right? Well, that's kind of how the story of Isaac Newton and the apple goes. But this isn't just any ordinary story. It's the beginning of a scientific revolution that changed the way we understand the world. Let's dive into the incredible journey of Isaac Newton, a man who turned a simple observation into one of the greatest scientific breakthroughs of all time. Isaac Newton was born in 1642, the same year that Galileo Galilei died. This wasn't just a coincidence. It was like the baton of scientific discovery was being passed from one brilliant mind to another. Newton was born into a world where science was just starting to take off. People were making amazing discoveries, but they were still struggling to understand the fundamental laws that govern the universe. Newton's early life wasn't easy. His father died before he was born, and when he was just 3 years old, his mother remarried and moved away, leaving him with his grandmother. This must have been incredibly tough for a young boy, and it probably contributed to the feelings of insecurity that Newton carried with him throughout his life. Despite these challenges, Newton showed a keen interest in learning from a very young age. He was curious and always eager to figure things out on his own. When Newton was 19, he went to Cambridge University, where he studied mathematics and physics. At Cambridge, he was exposed to the latest scientific ideas, including those of René Descartes, who believed that the universe was made up of tiny particles that moved and interacted in mechanical ways. Newton, however, was skeptical of these ideas. He believed that to truly understand the world, you had to rely on experiments and mathematics, not just theories. One of Newton's earliest and most famous experiments involved light and color. He took a prism, a triangular piece of glass, and used it to split sunlight into a rainbow of colors. This might seem simple to us now, but at the time, it was a groundbreaking discovery. People had always thought that light was pure, and that colors were just modifications of white light. Newton's experiment showed that white light was actually a combination of all the colors of the rainbow. He also discovered that each color of light had a different degree of refrangibility, which means it bends at a different angle when it passes through the prism. This was the foundation for a whole new science called spectroscopy, which is still used today to study the properties of light. But Newton's most famous contribution to science was his theory of gravity. The story goes that he was sitting under an apple tree when an apple fell on his head, and this inspired him to think about why objects fall to the ground. While the story might be a bit exaggerated, the idea is still true. Newton realized that the force that makes apples fall to the ground is the same force that keeps the planets in orbit around the sun. He called this force gravity, and he formulated the law of universal gravitation, which states that every object in the universe attracts every other object with a force that is proportional to the product of their masses, and inversely proportional to the square of the distance between them. In simpler terms, the bigger and closer two objects are, the stronger the gravitational pull between them. Newton's law of universal gravitation was a huge breakthrough because it explained not just why apples fall to the ground, but also why the planets move in the way they do. Before Newton, people thought that the planets moved in perfect circles, but Newton showed that they actually move in ellipses. This was a major step forward in our understanding of the solar system. But Newton didn't just stop at gravity. He also formulated the 3 laws of motion, which are still taught in physics classes today. The first law states that an object at rest will stay at rest, and an object in motion will stay in motion, unless acted upon by an external force. The second law states that the force acting on an object is equal to its mass times its acceleration. The third law states that for every action, there is an equal and opposite reaction. These laws are the foundation of classical mechanics and have countless practical applications, from designing cars to launching rockets. Newton's work wasn't just theoretical. He was also a practical scientist. He built his own telescopes and used them to make observations of the sky. He even improved the design of the telescope by using a mirror instead of a lens, which reduced the problem of chromatic aberration, where different colors of light bend at different angles and cause blurry images. This type of telescope, known as a reflecting telescope, is still used today by astronomers. Despite his many achievements, Newton was a complex and often difficult person. He was known to be highly competitive and could be very secretive about his work. He had a famous rivalry with Gottfried Wilhelm Leibniz, who independently developed the calculus, a branch of mathematics that Newton had also discovered. The two men argued for years over who had come up with the idea first, and the dispute caused a lot of tension in the scientific community. Newton's scientific achievements were recognized during his lifetime. In 1705, he was knighted by Queen Anne, making him the first person to be honored for scientific achievements in England. He also served as the president of the Royal Society, a prestigious scientific organization, for 24 years. But despite all the accolades, Newton remained humble about his work. He once said, "I do not know what I may appear to the world, but to myself I seem to have been only like a boy playing on the seashore, and diverting myself in now and then finding a smoother pebble or a prettier shell than ordinary, whilst the great ocean of truth lay all undiscovered before me." This quote shows that Newton understood the vastness of the unknown and the importance of continued exploration and discovery. Newton's influence on science and technology cannot be overstated. His work laid the foundation for modern physics and mathematics, and his ideas continue to shape our understanding of the universe. But Newton's legacy isn't just about his scientific discoveries. It's also about the way he approached science. He believed in the power of observation, experimentation, and mathematics to uncover the truths of the natural world. He rejected the idea that science should be based on untestable theories, and instead focused on developing laws that could be proven through careful measurement and calculation. Today, we live in a world that is profoundly shaped by Newton's ideas. From the way we build bridges and design aircraft to the way we understand the movements of stars and galaxies, Newton's laws of motion and gravitation are at the heart of modern science and engineering. His work has inspired generations of scientists and engineers to continue exploring the mysteries of the universe, and his legacy will continue to influence the world for many years to come. So, the next time you see an apple fall from a tree, remember Isaac Newton. Remember that sometimes the simplest observations can lead to the most profound discoveries. And remember that the quest for knowledge is a never-ending journey, one that each of us can contribute to in our own way.